Welcome students to our We4U Chemistry channel. Here you find unsolved question of KL Kapoor Volume 1. Today's video content is solution of 4 unsolved question of ionic equilibria related to mixture of solutions. In the above question, given nitrous acid concentration is 0.15 molar. Dissociation constant of nitrous acid is 4.5 multiplied by 10 raised to power minus 4. Acetic acid concentration is 0.20 molar. Dissociation constant of acetic acid is 1.8 multiplied by 10 raised to power minus 5. Both weak acids are present in solution. Reaction occurs in solution is nitrous acid dissociates and gives hydrogen and nitrite ion In, which nitrous acid equilibrium concentration are C1 multiplied by 1 minus alpha hydrogen ion concentration is C1 alpha 1 and nitrite ion concentration is C1 alpha 1. Acetic acid dissociates and gives hydrogen and acetate ion whose equilibrium concentration are C2 multiplied by 1 minus alpha 2 hydrogen ion concentration is C2 alpha 2 and nitrite ion concentration is C2 alpha 2. Total hydrogen ion concentration in solution is sum of C1 alpha 1 and C2 alpha 2. We can write dissociation constant formula for nitrous acid and acetic acid. Now put the value of equilibrium concentration of hydrogen ion, nitrite ion, nitrous acid, acetate ion and acetic acid in dissociation constant formula for nitrous acid and acetic acid. Degree of dissociation alpha 1 and alpha 2 are very small, so can be neglected in comparison to 1. Now divide dissociation constant of nitrous acid and acetic acid. After solving, we get the value of alpha 1 in terms of alpha 2, which is equal to Ka1 divided by Ka2 and multiply with alpha 2. Now put the value of alpha 1 in Ka1 equation and neglecting alpha in comparison to 1. On solving the equation we get alpha 2 value, which is equal to Ka2 divided by square root of C1 multiply with Ka1 plus C2 multiply with Ka2. Note: for mixture of weak acids, hydrogen ion can be direct calculated using square root of C1 Ka1 plus C2 Ka2 direct formula. Similarly, we can get the value of alpha 1 by putting the value of alpha 2 in terms of alpha 1. Alpha 1 is equal to Ka1 divided by square root of C1 multiply with Ka1 plus C2 multiply with Ka2. Now we have to calculate hydrogen ion concentration, which is equal to C1 alpha 1 plus C2 alpha 2. Now put the value of alpha 1 and alpha 2. On solving, we get hydrogen ion concentration is equal to square root of C1 multiply with Ka1 plus C2 multiply with Ka2. On putting the value of C1 0.15 molar Ka1 is 4.5 multiply with 10 raised to power minus 4, C2 is 0.2 molar and Ka2 is 1.8 multiply with 10 raised to power minus 5. We get hydrogen ion concentration is 8.43 multiply with 10 raised to power minus 3. Similarly, nitrite ion is 0.15 multiply with 0.45 divided by 8.43, we get the value which is raised to 8 multiply with 10 power minus 3. Acetate ion concentration is 0.2 multiply with 0.018 divided by 8.43. We get acetate ion concentration is 430 multiply with 10 raised to power minus 4. Answer: hydrogen ion concentration is 8.43 multiply with 10 raised to power minus 3. Nitrous ion concentration is 8 multiply with 10 power minus 3 and acetate ion concentration is 430 multiply with 10 raised to power minus 4. In the above question, a solution contains 0.20 decimeter cube of 4.0 m acetic acid and 0.60 decimeter cube of 0.80 molar hydrogen cyanide. Molarity of acetic acid in solution is molarity of acetic acid multiplied by volume of acetic acid divided by total volume, which is 0.80 decimeter cube. Molarity of acetic acid in solution is 1 molar. Similarly, molarity of hydrogen cyanide in solution is molarity of hydrogen cyanide multiplied by volume divided by total volume. Molarity of hydrogen cyanide in solution is 0.6 molar. Acetic acid dissociates and gives hydrogen and acetate ion which has degree of dissociation alpha 1. Hydrogen cyanide dissociates and gives hydrogen and cyanide ion which has degree of dissociation alpha 2. For mixture of weak acids, alpha 1 can be direct calculated using Ka1 divided by square root of C1 Ka1 plus C2 Ka2. Alpha 2 can be direct calculated using Ka2 divided by square root of C1 Ka1 plus C2 Ka2. Now we can find out acetate ion, cyanide ion concentration. Acetate ion concentration is equal to C1 alpha 1. On solving, acetate ion concentration is 4.25 multiplied by 10 raised to power minus 3. Cyanide ion concentration is multiplication of C2 and alpha 2. On putting the value of hydrogen cyanide concentration and alpha 2. On solving, cyanide ion concentration is 0.56 multiply with 10 raised to power minus 7. Answer: acetate ion concentration is 4.25 multiply by 10 raised to power minus 3. Cyanide ion concentration is 0.56 multiply with 10 raised to power minus 7. In the above question, Part A given is the concentration of sodium hydroxide is 0.02 molar. Sodium hydroxide is a strong base. Sodium hydroxide dissociate and give sodium ion and hydroxide ion. Hydroxide ion concentration in solution is 0.02 molar. Hydrogen ion concentration can be found out using dissociation constant of water divided by hydroxide ion concentration. Hydrogen ion concentration is 10 raised to power minus 14 divided by 0.02. Now we know the value of hydrogen ion, we can calculate pH. pH is minus log of hydrogen ion concentration. On solving, pH value is equal to 14 minus 1.69 which is equal to 12.30. In Part B, sodium hydroxide concentration is 1.5 multiply with 10 raised to power minus 7. As sodium hydroxide concentration is very low, we cannot ignore hydroxide ion coming from water. Water dissociates and gives hydrogen and hydroxide ion. According to charge balance equation, sum F positive charge ion is equal to sum of negative charge ion. Sum of hydrogen and sodium ion is equal to hydroxide ion. Putting the value of hydrogen in terms OS hydroxide ion, we get a quadratic equation in hydroxide ion. On solving, hydroxide ion is equal to sum of concentration of sodium hydroxide and square root of concentration of sodium hydroxide plus 4 multiply with dissociation constant of water divided by 2. On solving, hydroxide ion concentration is 2 multiply with 10 raised to power minus 7 and hydrogen ion concentration is 0.5 multiply with 10 raised to power minus 7. pH is equal to minus log of hydrogen ion concentration. On solving, pH of the solution is 7.30. Always remember, while calculating pH you should consider hydrogen or hydroxide ion from water, if acid concentration is low. Answer: Part A pH is 12.30 and Part B pH is 7.30. In the above question, ammonium hydroxide concentration is 0.015 molar. Dissociation constant of ammonium hydroxide is 1.85 raised to power minus 5. Ammonium hydroxide dissociates into ammonium and hydroxide ion. Ammonium hydroxide is C multiplied by 1 minus alpha. Ammonium ion is C alpha and hydroxide ion is C alpha. Dissociation constant is C multiplied by alpha square and 1 minus alpha. Alpha is small value in comparison to 1. Alpha is equal to square root of dissociation constant divided by concentration of ammonium hydroxide. On solving, alpha value is 3.51 multiplied by 10 raised to power minus 2. If ammonium hydroxide is diluted to 100 times, then ammonium hydroxide concentration is 1.5 multiplied by 10 raised to power minus 4. In this situation, alpha value cannot be ignored in comparison to 1. On solving dissociation constant equation, we get a quadratic equation in alpha. C alpha square plus kb alpha minus kb equal to 0. On solving, alpha can is equal to minus kb plus square root of kb square plus 4 multiplied by kb divided by 2c. On putting the value of kb and concentration in alpha equation, we get alpha value equal to 0.2949. As you can see, alpha value cannot be ignored in comparison to 1. Now we know the value of alpha, we can calculate hydroxide ion concentration, which is C into alpha. pOH value is minus log of hydroxide ion concentration. After knowing pOH value, we can find out pH, which is 14 minus pOH. On solving, pH value before dilution is 10.72. pH value after dilution is 14 plus log of 0.2949 multiply with 0.00015. On solving, pH value is 10.35. In part B, we have to calculate weight of ammonia. Ammonia plus water give ammonium ion and hydroxide ion, whose dissociation constant value is 1.81 multiply with 10 raised to power minus 5. Given hydroxide ion concentration at equilibrium is 1.81 multiply with 10 raised to power minus 3. Dissociation constant is equal to multiplication of product concentration divided by multiplication of reactant concentration. After putting the value of dissociation constant, ammonium hydroxide and ammonia value, we get the linear equation in alpha. On solving, alpha value comes out to be 0.01192. Hydroxide ion concentration is C alpha, which is equal to 1.5 multiplied by 10 raised to power minus 3. Now putting the value of alpha, concentration of ammonia is equal to 0.1258 molar. Now we know the value of molarity of ammonia, volume and molecular mass. After solving, mass of ammonia is required is 21.386 gram. In part C, given 50 cm³ of 6m ammonia. To double the percent conversion, degree of dissociation also becomes double. Alpha 2 is equal to twice of alpha 1. Ka is equal to C1 alpha 1 squared divided by 1 minus alpha 1. Ka is equal to C2 alpha 2 squared divided by 1 minus alpha 2. Degree of dissociation value is very low and can be neglected in comparison to 1. Dissociation constant does not change on dilution. So C1 alpha 1 square is equal to C2 alpha 2 square. On putting alpha 2 value, we get concentration of ammonia after dilution is initial concentration of ammonia divided by 4. 1 is equal to 6 molar. C2 is 5 molar. No. Of moles of ammonia remain same before and after dilution. C1V1 equal to C2V2. On solving, total volume comes out to be 200 cm³. Water required to convert double the percent conversion of ammonia into ammonium ion is 200 minus 50 equal to 150 cm³. Answer: part A pH is 10.72, alpha 1 is 0.0351. After dilution pH is 10.35 and alpha 2 is 0.2949. Part B mass of ammonia equals 21.386 gram. Part C water required for double conversion is 150 cm³. Don't forget to like, share, and subscribe, and we'll see you in the next video. That's right. If you have any questions, whether it's related to the topic of this video or any other academic subject, drop them in the comments, and we will be more than happy to help you out.